We are now finishing the cycle of teaching practices. Near the end of a unit of instruction, students should be assembling parts of their final explanation for the anchoring event. It is at this point that the teacher asks them to select one claim that is important to their explanation and support that claim with evidence. This is a scientific practice of argumentation. Once these claims have been shared and debated in class, the students take all of what they've learned during the unit and create their final explanatory models along with the written explanation. This is not the end of the unit. The teacher may see gaps that persist in students' explanations and decide to reteach important ideas. Or the teacher may ask students to apply their models to different phenomena. Or the teacher may elect to conduct more formal assessments of learning to culminate their work together. To start my novices on the scientific practice of argumentation, I model for them how a teacher might help young learners understand what a claim is. I do this by contrasting the everyday uses for the word claim with scientific meanings. This exercise helps young learners develop skills with academic language.
Okay, so let's break it down. I heard Dennis say it's about the natural world. A claim for us is going to be some statement about the natural world. You should be able to make some predictions based on that claim. It's something that you think is true. And the claim is not clear-cut. It needs some evidence for support. Remember on Tuesday I asked you to think about one claim, one statement that you could make that's embodied in your model somewhere. And I want you to use these criteria. It's got to be something about your model. It's got to be something maybe you could base a prediction on, something you think is true and something that you think is supportable through evidence. And so I have a guide for you. I'm going to give this out right now. Esther, can you pass this around? I want you just to look on the left side of this guide. I have at the top some sentence starters for you to help you develop a claim. Whatever is in brackets in the sentence starters, this is how explicit you have to be with kids, because they don't know about these conventions. When you see a set of brackets, and right now I want you to point to the brackets, so everybody in your group sees where the brackets are. What that means is that you should fill in something that you think goes inside those brackets to complete the sentence, or to complete the claim. In that first box, you've got one set of brackets that you have to put a statement into. Then down below, there's a statement about evidence. If this claim or explanation is true, then when I look at a particular kind of data, and then you have to describe what kind of data it is that you might look at, I would expect to see a particular kind of trend or an outcome. So you need to express that. You have two brackets to fill in there. And at the bottom is the hardest part. It's putting the two together, where you're taking your evidence and you're saying, here's why my evidence supports my claim. And so I've got a sentence frame for that. So for us, evidence has to be data. And data can come either from your population charts or the charts of the abiotic, like the temperature swings over the last 30 years. The other data that we have is from the energy activity that we did where we passed beams around. So don't try when you make your claim to make your claim a huge, expansive, full-blown explanation of your whole model. I just want you to pick a small piece of the model. You might have very different claims here, which would be great.
The Adelie penguin population is decreasing because of the increased competition with chinstrap penguins for nesting sites. So our niches reading, our evidence is that our niches reading said that chinstraps are successfully pushing Adelie penguins out of their nesting sites.
Okay.
And we
there's an increase.
Further know this information because the chinstrap penguin population, we may have these things, went from 1,000 breeding pairs in 1976 to 76,000 breeding pairs in 2013.
During that time
Yep.
period. Well, that's
And then we also know that the Adelie penguin population decreased from 93,000 in 1976 to 3,000.
How's that different?
That's our evidence.
That is our evidence. Oh.
I
thought you said this is our reasoning. I was like, what?
No. And then our reasoning is
Sorry.
chinstrap population is increasing, as you noted from our evidence. And we know that if it's increasing, they need even more breeding spots, so that we know that they're going to be pushing the Adelies off the existing Adelies off their nesting sites, so that the chinstrap population will continue to increase and the Adelie population will continue to decrease. Which means that the decrease is caused by competition.
During this activity, after groups have expressed their claim, evidence, and reasoning, they pair up with other groups to act as friendly critics to one another. This helps them articulate the parts of their argument and to offer feedback for improving their reasoning. The middle column on the guide helps with this process.
So now we fill in the middle column by giving you feedback.
About what is causing something to happen.
Yeah,
I think so.
I think that's pretty clear.
Can you reread that?
Maybe rephrase the claim to put in the box to make sure that you guys are understanding what they claimed. Like,
The Adelie population
I don't know.
is declining because of increased competition with chinstraps.
okay.
That's
That's what you said? Okay.
That's exactly what.
Oh, alright. Just
Yeah, that's
an
an
idea.
technique.
Yeah, just an idea.
Yeah.
The classroom asks them to rephrase it.
He secretly was reading it.
Like more clear. I'm not going to complain till we get to the evidence box.
Okay.
But like with students, the claim, they may use pronouns, and so a way to clarify is to it, they, them, the penguins, well, which penguins, so students may have more to poke at.
Hypothesis, does it need to be testable? Or not? I mean, a hypothesis should be testable. I'm just,
Is this
It
a
needs
claim
to
or
be
not?
a statement that you can defend with evidence.
like, you don't necessarily need people to test it.
You've already done your test.
Some evidence to
the
support
explanation behind that evidence. So my evidence is
Yeah. So
these
is it
numbers
claim and
trends that are
hypothesis very close?
correlated.
Like they're really.
Yeah, I was wondering what the
Most
difference is.
accessible way
I think a
to read it.
hypothesis is a guess, whereas a claim
Call it
is,
a causation.
we've done the
With some
experiment,
evidence.
we've
You
collected
already have the
evidence,
data.
and we
So
ask.
that's how you make a hypothesis.
A hypothesis. A hypothesis can be supported or refuted by evidence. Is a claim different from a hypothesis in that it must be supported? Like, if your hypothesis is wrong, that's just fine. That's still good information.
Yeah, I think it's different. It comes at a different point. I don't think you would make a claim before you collected any data at all.
Well-
Whereas you might make a hypothesis.
So what's different in your initial models? When you're trying to explain something you can't observe, aren't those claims or are those hypotheses?
So
Or
hypothesis.
does it matter to a
I
kid?
would call them hypotheses.
Okay.
So hypothesis is something I think which you can make even before doing any investigation.
So it's more like an inference.
And that's something testable. You test later. And claim is
Mostly,
something
okay.
which you make after you have done all the investigations.
It's your conclusions.
It's technically your conclusion, yeah.
But then what happens with the hypothesis and prediction if we put the focus on learning science and claim against reasoning?
It's a good question. That's what I'm struggling with, yeah.
There can be two ways in which we can use evidence. First of all, we can compare the number of breeding pairs for Adelie penguins and the chinstrap penguins. The other thing which we thought would be also helpful is relate the percent of precipitation events that are snow with that from the number of breeding pairs of Adelie penguins. So we also said that as the percent precipitation of snow events are increasing, the number of Adelie penguins population is decreasing.
But
Is that related to the claim?
so wouldn't that also decrease chinstrap population?
Yeah.
But how is that related to the claim?
So, you want to say that? That's right.
Our claim is that
Mean to me attack.
the two populations are related, but that they're related by the fact that snow was increasing.
It's not pushing them off the nest,
It's the amount of precipitation.
Yes.
The amount of snow actually decreases the number of nesting sites, so the fact that they're competing actually makes it more significant because there's actually less sites to compete over now. But when they're doing their whole evidence-based explanation, do you expect them to pull out all of their labs and look at all of the numbers and then pick the numbers and then put the numbers
I
on?
would expect them to look at all the labs, yes, but not necessarily quote the data.
For this activity, you do quote data because you're making a claim about a small piece of the entire explanation. And I don't know what Mark has said about like having students to have a student write the entire explanation for this penguin phenomenon with evidence for every claim about the model would be insane.
So we see there's an increase in that graph under this time period. We also see a decrease in the Adelie population during that time period. So while that's going up, that's going down.
Can you repeat your evidence?
Yes. This claim is true because when I see an increase in the graph for the precipitation events that are snow over a certain time period, I also see a decrease in Adelie population data in the same time period. The reason why I see this is because Adelies need snow-free ground to breed, and more snow events means there's less time without snow and therefore less breeding.
I would want to know next, what is the evidence that snowfall is causing, or what is the evidence that snowfall reduces Adelie's ability to breed and reproduce?
Right, that's
because you've got the evidence that they're correlated, but I want to know that it causes it as well.
And that's part of the reasoning.
Yeah,
that's your reasoning.
Yeah, our reasoning says that Adelies need snow-free ground to breed, so if there's more snow occurring, therefore there's less breeding.
Would you put the Adelies need snow-free ground to breed into the evidence section?
Because that wasn't from any data, like any
Not
graph.
a graph, it was from
It was from just the readings that we got. Yeah.
So, would you include that reading as more as evidence, and then maybe revise your reasoning, or just a thought?
I wouldn't, just because I think of personally evidence as more data-backed, and the reasoning would be the explanation behind that evidence. So my evidence is these numbers and the trends that are, the correlation is my evidence, but the reasoning gives me the reasoning to call it a causation, I guess.
What's convincing you that it's not just correlation, though?
Yes. Okay. I've had this question the whole time.
Wait, what?
Like, who's to say that the snowfall increase and the decrease in Adelie populations isn't just a coincidence?
So maybe in your reasoning you would have to explain more about why this isn't just correlation and it's actually causation.
So more evidence that, like, or more of an explanation would be helpful as to why the snowfall reduces Adelie breeding.
Maybe be more explicit.
More explicit, more maybe an article or something that shows it.
Talk about maybe why some of the other pieces of data, why the other things that are happening couldn't be used to explain what you're seeing.
Ooh, there you go.
Which I think is one of the prompts in our reasoning.
And then maybe ask questions about data you could use.
For what?
To rule out the coincidence possibility.
So our claim is, we believe that a decrease in krill population causes a decrease in Adelie population. So our evidence is, when you look at the data of the krill and the Adelie, you should see a decrease in Adelie whenever you see a decrease in krill. So the reason we expect to see the correlation is that we know Adelie primarily eat krill to live. If the Adelie don't get enough food, their population would decline.
Well, my first question, real quick, is what about when the krill increases and there's no increase in the Adelie population?
Like in 1993?
Yeah,
What's an example? Well, like here it goes up, here it goes up, here it goes up, and here it goes up. So there's 4 places where the krill is increasing, but there's no corresponding increase in the.
If we could revise our, rewrite it, I'd probably say, instead of saying whenever it goes down, the Adelie goes down, I'd rephrase that and say just like the general trend of the data is downward, and so is the general trend of the Adelie population.
I remember somebody's idea from the very beginning of the unit was that the krill population maybe fluctuates more easily, like it's a pretty, maybe they have shorter life cycles. And so you might see more fluctuations in their population, whereas Adelies live longer, so you might not see the same dramatic up and down swings in there.
So how could, a good next step, like how could you create the circumstances to test your claim further? Like maybe it's...
Or what more evidence do you need, and how could you produce that evidence?
That would be great.
I'm really happy you said that, because in my head I was like, we should dump a bunch of krill in the water and see like what happens. So it's a cool idea.
Something I was thinking about your point is that what we wanted to include this, but we needed to be succinct, is that the fact that krill is a keystone species, so that sea leopards and also the chinstrap penguins feed on krill. And so that has, we were saying how that affects the krill population, but we weren't sure exactly how to include that in here. Kind of had to like.
That could tie in with how variable the population is. If you wanted to add that to your reasoning, I mean, it like kind of like that rebuttal thing, showing why the opposite isn't true. Oh well, you don't see that, or we can explain this variation in the data because it's a keystone species and it's being preyed upon by a lot and it has a short life cycle.
Near the end of class, we debrief our experiences with the guide. In the process, we changed some of the scaffolding so that all of us could use a version of this in our classrooms.
Additional data could we collect, or Marie was talking about, could we run an experiment in the Antarctic about Adelies in their food or Adelies in the snowfall? What would that experiment look like if we could do that?
So you're talking about asking this of the kids, or what's the point of
Asking that of the kids, it gets them to take their knowledge of that ecosystem and saying, in order for us to support this claim with stronger evidence, and maybe multiple forms of evidence, we can imagine an investigation we could conduct that would tell us, for example, that the relationship between the snowfall and the declining Adelies is not just correlated, but one is actually causing the other. What experiment could we do that would take us from correlation between those two to the snowfall actually causing the decline of the Adelies?